Hey everyone, before we dive into the story, make sure to hit that subscribe button and give this video a like. Trust me, by the time we're done, you're going to want to be part of this channel. On November 5th, 2018, a tense, almost funeral silence hung over the Mission Control Center at NASA's Jet Propulsion Laboratory. On the monitors, glowing green lines of code scrolled past telemetry that took 16.5 hours to reach Earth. It was a signal from Voyager 2, the loneliest and most distant human-made object still operating normally. Engineers, many of whom had dedicated their entire lives to this project and had grown old alongside it, stared at the graphs in disbelief. The plasma sensors, ancient instruments built in the era of disco and the Cold War, had suddenly registered a sharp, inexplicable spike. The ambient temperature jumped to tens of thousands of degrees. Particle density shot up. It was as if the probe, flying through the absolute freezing void at the edge of the solar system, had slammed into an invisible concrete wall or flown into the mouth of a volcano. But there were no volcanoes, no stars, no planets around. Only the eternal, impenetrable darkness of billions of kilometers. At first, they thought it was a glitch. That would have been logical. The spacecraft had been operating in extreme conditions for over 40 years. Its computer memory is millions of times smaller than that of your smartphone. The systems are worn out, its generator is dying. But when the data was double-checked and compared with readings from its twin, Voyager 1, which had passed this way 6 years earlier but at a different location, there was no doubt left. It wasn't a glitch. It was a discovery. Voyager 2 had indeed run into something. It had hit a physical boundary of our domain, the edge where the sun's influence ends and the unknown, hostile ocean of interstellar space begins. We are used to imagining space as emptiness, as an infinite nothing where you can fly straight forever without meeting any resistance. We look at the night sky and think the stars just hang there in a vacuum. But the data coming from the edge of our world shatters that illusion. The solar system is not an open frontier. We live inside a giant bubble, sealed on all sides, and the walls of that bubble are not a metaphor. They are a raging, superheated plasma, a wall of fire and radiation that separates us from the galaxy. Today, we will take the most detailed, deepest dive into the story of this incredible journey. We will examine exactly what the Voyagers saw when they broke through that wall, why scientists call this zone a firewall, where temperatures of 30,000 degrees come from when there are no heat sources nearby. We will learn why the true shape of our home is not a sphere, but rather a squashed croissant or a crippled insect. And finally, we will answer the most frightening question. What lies beyond that wall? Is it true that we are trapped in a local prison? And is there something out there in that darkness watching us? To understand the scale of what happened at the edge of the solar system in our time, we need to rewind the tape of history far back to the middle of the 20th century. Back then, humanity was only learning to take its first uncertain steps beyond the atmosphere. Rockets exploded on the launch pad, satellites fell, and no one dreamed of flying to the stars. But in 1965, a young intern at the Jet Propulsion Laboratory named Gary Flandreau made calculations that changed everything. He was plotting the orbits of the giant planets Jupiter, Saturn, Uranus, and Neptune, and noticed a striking pattern. Once every 176 years, these four giants align in a long, curved arc. It was an extremely rare planetary alignment, and Flandreau realized that if a spacecraft was launched at exactly that moment, in the late 1970s, it could perform a grand tour. The probe could fly past all four planets in a single go, using the gravity of each as a giant slingshot. A gravity assist is a trick of celestial mechanics. When a spacecraft approaches a planet, it essentially falls toward it, speeding up, but instead of crashing, it swings past, stealing a tiny amount of the planet's orbital energy. The planet slows down by an infinitesimal fraction of a millimeter per century, while the tiny spacecraft receives a monstrous boost, catapulting it toward its next target. Without this maneuver, a flight to Neptune would take 30 years, with the planetary alignment only 12. It was a once-in-a-lifetime chance. If NASA had missed the launch window in 1977, the next opportunity would not come until 2153, well beyond any of our lifetimes. So the decision was made instantly. We go. The project was named Voyager, meaning traveler. Two identical spacecraft were built, Voyager 2 and Voyager 1. The numbering can be confusing. Voyager 2 was launched first on August 20th, 1977, and Voyager 1 followed on September 5th, but along a faster trajectory, so it was destined to overtake its twin. Let's take a moment to appreciate these machines. They are the pinnacle of 1970s engineering. Each probe weighs 723 kilograms. It has a large white dish antenna 3.7 meters in diameter to communicate with Earth. It has eyes or television cameras on a movable platform. It has ears, plasma wave receivers. And it has a heart, 3 radioisotope thermoelectric generators. These are not solar panels. Where they were headed, the sun shines no brighter than a distant star. Solar panels would be useless, so the Voyagers are powered by the decay of plutonium-238. Hot spheres of plutonium produce heat, which is converted into electricity. At launch, each generator produced about 470 watts, less than your microwave oven consumes. And on this energy, the spacecraft had to run its computer, warm its instruments, move its cameras, and send a signal across the abyss. Now think about the technology. Voyager's computer system has only 68 kilobytes of memory. 68 kilobytes. One photo on your phone weighs 1,000 times more than the entire memory of the spacecraft. Data was recorded on an 8-track tape recorder. If the tape broke or jammed, the mission would be over. The transmitter has a power of 23 watts, about the same as a light bulb in a refrigerator. And with that whisper, Voyager had to shout across billions of kilometers. The engineers built in an incredible margin of safety. They duplicated systems, shielded cables with aluminum foil against interference, used radiation-hardened components. They built these probes as if the fate of humanity depended on it. And as it turned out, they were right. The flight to Jupiter took nearly 2 years. In March 1979, Voyager 1 approached the king of planets, and what it sent back shocked scientists. Until then, Jupiter had been seen only through telescopes as a blurry, striped spot. Voyager revealed it as a boiling, dynamic world. It saw the Great Red Spot, a hurricane 3 times the size of Earth that has been raging for centuries. It saw complex atmospheric vortices rotating in opposite directions. But the main discovery was not on the planet itself, but on its moons. Io, a moon the size of our own moon, turned out to be the most volcanically active body in the solar system. Right before the astonished scientists' eyes, Voyager photographed volcanoes erupting, spewing sulfur hundreds of kilometers into space. That overturned the idea that moons are dead rocks. It turned out that Jupiter's gravity needs Io like putty, heating its interior. Then came Europa, a smooth, icy globe, covered with cracks but no craters. This led scientists to suspect that beneath Europa's ice lies a vast ocean of liquid water. An ocean with more water than all of Earth's seas and rivers combined. That was the first hint that life might exist not only on planets but also in the icy abysses of distant moons. Given a powerful gravitational kick from Jupiter, the Voyagers raced towards Saturn. The encounter took place in 1980 and 1981. Saturn, the Lord of the Rings. The Voyagers showed that the rings are not solid disks, but thousands upon thousands of thin strands, made of icy boulders and dust. They saw shepherd moons, tiny satellites whose gravity keeps the rings in order. But it was at Saturn that the paths of the twins diverged. NASA had a choice. Voyager 1 could fly on to Pluto, but then it would miss Titan, Saturn's mysterious moon, the only moon with a thick atmosphere. Scientists decided to sacrifice Pluto for Titan. They sent Voyager 1 on a risky close approach. The probe passed only a few thousand kilometers from Titan, trying to peer through the thick orange haze. It did not see the surface, but its sensors analyzed the atmosphere and found organics. Methane, ethane, complex hydrocarbons. It was a factory of prebiotic chemistry. Titan resembled a frozen Earth at the dawn of life. After that maneuver, Voyager 1 sharply angled upward, perpendicular to the ecliptic plane. Its planetary mission was over. Now its path lay into the black void, away from all known celestial bodies. It became a lone wanderer whose only goal was to fly as fast and as far as possible. Voyager 2, however, continued the grand tour. Uranus and Neptune awaited it. In January 1986, it flew past Uranus. This is a strange, pale blue world that rolls along its orbit lying on its side. Uranus looks like a calm, almost boring ball of gas, but its magnetic field turned out to be insane offset from the planet's center and tilted at a wild angle. Voyager discovered new moons and rings around Uranus that no one had suspected. And finally, August 1989, Neptune, the last outpost. The farthest planet, Pluto was still considered a planet back then, but it is small and far away. Neptune greeted Voyager with storms. Scientists saw the Great Dark Spot, an analog of Jupiter's spot, a giant hurricane where winds blow at 2,000 kilometers per hour, the fastest winds in the solar system. Voyager flew past the moon Triton and saw geysers of liquid nitrogen. Imagine minus 235 degrees Celsius. And from beneath the ground, fountains of nitrogen shoot up, instantly freezing and falling back as black snow. That was the end of the planetary part of the mission. Both spacecraft had fulfilled their tasks 1,000%. They discovered dozens of new moons, explained the nature of rings, showed us volcanoes and oceans where we expected only ice and rock. By all logic, the program could have been shut down. Funding was cut. Many engineers retired or moved on to new projects. But the Voyagers did not die. Their nuclear hearts kept beating. And then a new mission began, a mission without a clear name but with a grand purpose. The Voyager Interstellar mission. The goal was to find the edge, to find where the sun ends. The 1990s and 2000s became a time of great silence. The spacecraft were moving away from us at 17 kilometers per second. Communication grew ever harder. The signal weakened. To catch their voice, Earth had to combine the giant antennas of the Deep Space Network into a single system. All that time, they were flying inside the Heliosphere. The Heliosphere is the realm of the sun's dominance. Our star is not just a light bulb. It is a nuclear fusion reactor that constantly ejects millions of tons of matter. This flow is called the solar wind. It consists of protons, electrons, and alpha particles. This wind blows at speeds from 300 to 800 kilometers per second, inflating a huge bubble around the solar system, pushing back the interstellar medium. As long as the Voyagers were inside this wind, they were home. But scientists knew that sooner or later, the pressure of the solar wind would weaken. It would balance against the pressure of the interstellar gas pushing from outside. That balance point is called the termination shock, the first barrier, the first line of defense of our system. Voyager 1 reached that line in December 2004, at a distance of 94 astronomical units from the Sun, about 14 billion kilometers. Its instruments showed that the solar wind had abruptly slowed down. Before that, it had been moving faster than the speed of sound. In plasma, sound has its own speed. Now it became subsonic. Imagine a supersonic jet slamming on the brakes. A shock wave forms, a compression. The plasma temperature rose, and the magnetic field became chaotic. Voyager had entered the heliosheath, the outer layer of the bubble, the meat between the skin and the bone. Here the solar wind no longer flows smoothly. It churns, swirls into vortices, mixing with particles leaking in from outside. It is a zone of turbulence. Voyager 1 flew through this chaos for 8 long years. 8 years through a plasma storm. Then came 2012, a year that went down in history. Voyager 1's data began to show something strange. The number of particles coming from the sun started to drop. First slowly, then in jerks, falling, returning. The probe seemed to be diving into waves on the ocean shore. It was at the very edge. On August 25, 2012, all instruments registered a definitive change. The solar wind disappeared completely, zero silence. And in its place, the sensors were flooded with galactic cosmic rays, ultra-high-energy particles accelerated by supernova explosions and black holes somewhere deep in the Milky Way. Their intensity shot up many times. This was the moment of truth. Voyager 1 had crossed the heliopause. It had exited. But the joy was mixed with confusion. The data did not match theoretical models. Scientists expected that when entering interstellar space, the direction of the magnetic field would change. Inside the bubble, the field is dictated by the sun, outside by the galaxy. They should be pointing in different directions. But Voyager 1 did not detect a change in direction. The field strength increased, it became tighter like a stretched string, but the compass needle did not budge. That sparked years of debate. Skeptics cried, "It hasn't left at all. It's still in some weird pocket of the heliosphere." They proposed a theory of a magnetic highway, that the sun's and galaxies' field lines had intertwined, creating a tunnel. Voyager was just riding that tunnel but was still in the hallway. Confirmation was needed. They had to wait for the second scout. Voyager 2 lagged behind by 6 years and was flying on a different trajectory to the south. When it reached the boundary in 2018, it put an end to the arguments. Its transition was different, sharper, more distinct. In one day, the readings changed radically. And unlike its twin, Voyager 2 had a working plasma spectrometer. The one on Voyager 1 had failed back in 1980. Thanks to this working instrument, we were able to directly measure the temperature and density of the medium. And that is when the wall of fire was revealed. Voyager 2's instruments showed that immediately beyond the heliopause, the plasma temperature ranges from 30,000 to 50,000 Kelvin. That seems absurd. Space is absolute zero minus 273 degrees Celsius, right? So where is the heat coming from? As if inside a nuclear reactor? Here we need to take a deep breath and understand the physics. In space, the concepts of heat and temperature are decoupled. On Earth, if you stick your hand into a 200-degree oven, you will get burned because the air is dense. Billions of molecules strike your skin every nanosecond, transferring energy. In interstellar space, the vacuum is nearly perfect. There may be only 1 or 2 particles per cubic centimeter. Temperature in physics is a measure of the kinetic energy, the speed of those particles. The particles beyond the heliopause are racing at insane speeds, so their formal temperature is high, tens of thousands of degrees. But because there are so few of them, they cannot transfer heat to the spacecraft. If you stuck your hand out of Voyager, you would not burn, you would instantly freeze. The spacecraft continues to cool, even though it is flying through hot plasma. So why are those particles so fast? Where does the energy come from? It is the result of 2 worlds colliding. The solar bubble does not just hang in emptiness. It is moving, and it is colliding with the interstellar wind. At the collision site, the plasma is compressed and heated. It is like a wave of water building up in front of a fast-moving ship. The Voyagers punched through that wave. This discovery proved that our solar system is surrounded by a hot, fiery shell. We are like the yolk in an egg surrounded by egg white, and only then comes the shell. This shell plays a critical role. It acts as an additional filter. Without it, the amount of galactic radiation reaching Earth would be even higher. This wall of fire burns away some of the dangerous particles, keeping them out. We should be grateful to this wall. The discovery of the wall of fire is only the tip of the iceberg. The data that the Voyagers and their colleague, the IBEX spacecraft, which scans the system's boundary from Earth orbit, have sent back over the last 5 years has forced us to completely rethink what our home looks like from the outside. If you open old astronomy textbooks from the 1990s or 2000s, you will see a picture where the Heliosphere is shown as a comet. A round head with the sun and planets inside, and a long, long tail stretching billions of kilometers behind like a ship's wake. That seemed logical. We are flying through the galaxy, so there should be a trail behind us. But reality turned out to be far stranger and more chaotic. In 2020, a team of astrophysicists led by Merav Ofer of Boston University, using new Voyager data, built an updated 3-dimensional model of the Heliosphere. When the computer finished rendering, the scientists did not see a comet. They saw a deflated croissant, or, if you prefer, a giant shrimp without its shell. Our heliosphere does not have a long tail. It is squashed. It has 2 short, curved protrusions at the rear, and between them a gap. Why is the shape so ugly and irregular? Why does our protective bubble look as if it has been chewed by a giant cosmic dog? The answer lies in an invisible battle of magnetic fields. The sun is not only a source of light and wind, it is a giant magnet. And because the sun rotates on its axis every 27 days, its magnetic field gets twisted into a spiral. Imagine a ballerina's skirt spinning in a pirouette. This magnetic skirt extends to the very edge of the system. But outside, there is also a magnetic field, the interstellar field of the galaxy itself, and it presses against our bubble with monstrous force. That external field crumples the tail of our heliosphere, preventing it from stretching out. It deforms our shield, flattening it from the sides. This discovery is frightening because of its instability. We thought we lived in a perfect sphere, but it turns out we live in a pulsating, distorted sac that constantly changes shape under the blows of galactic waves. Moreover, this sac is leaky. The Voyagers discovered a process called magnetic reconnection. This is where the sun's magnetic field lines break and connect with the galactic field lines. Holes, tunnels form cosmic highways through which matter can freely flow in and out. This means our quarantine is not perfect. The galaxy is constantly feeding us its material, and we do not always know what exactly flies in through those open windows. Now let's talk about why the pressure outside is so strong, why the external environment is so aggressively attacking our bubble. In 2020, while analyzing data from Voyager 2, scientists noticed another anomaly that defies intuition. How do we usually picture space? The farther from a star, the emptier it should be. Inside the system, there is plenty of dust, gas, and solar wind. Outside, there should be a perfect vacuum. But the instruments showed the opposite. As soon as Voyager 2 left the heliosphere and flew a little further, it detected an increase in electron density. The plasma density outside turned out to be higher than inside, in the tenuous solar wind. We flew to freedom, into emptiness, and we flew into a thick fog. We are like a submarine that surfaced from the depths only to find that the water above is even denser. This confirms the theory that the solar system is currently passing through a local interstellar cloud. It is a giant clump of gas and dust about 30 light-years across. We entered it roughly 40,000 to 60,000 years ago, by cosmic standards just yesterday, and we will continue to fly through it for another 10,000 to 20,000 years. Where did this cloud come from? It is the remains, the ash, the graveyard. We live in a region of the galaxy called the local bubble. This is a huge cavity in the interstellar medium, hundreds of light-years wide. This cavity formed millions of years ago after a series of catastrophic supernova explosions. Imagine 10 or 15 massive stars exploding one after another, like a chain reaction of mines in a field. The shock waves from those explosions swept all the gas out of this region, creating a bubble of hot, rarefied gas. And the local interstellar cloud through which we are now sailing is a clump of the debris from those explosions, shreds of matter that did not disperse. This cloud consists of hydrogen, helium, dust, and traces of heavy elements born in the nuclear fire of dying stars. We are literally breathing the ashes of our stellar ancestors. It is this cloud that creates the pressure that squeezes our heliosphere into a croissant and builds the wall of fire at the boundary. We are flying through resistance. And this leads us to the most alarming scenario that astrophysicists warn about, the scenario of a galactic winter. We are accustomed to stability. It seems to us that the sun always shines the same, and the space around us is unchanging. But the solar system is a bullet flying at 230 kilometers per second around the center of the galaxy. Along its path, it encounters different weather conditions. Right now, we are in a relatively thin cloud. But what if we fly into a truly dense nebula? Voyager's data allows us to model that. If the density of interstellar gas increases by a factor of 100 or 1,000, and such clouds do exist on our path, the pressure on the heliosphere would become catastrophic. Our bubble would begin to shrink. First, the boundary that the Voyagers crossed at 120 astronomical units would move inward to Pluto's orbit, then to Uranus, then to Saturn. If the compression continues, the heliosphere could shrink to the size of Earth's orbit. What would that mean for us? We would lose our shield. Cosmic rays, lethal galactic radiation, dust particles, would all pour into Earth's atmosphere. This would destroy the ozone layer. The radiation background on the surface would rise, causing mutations and cancer. The climate would change. Dust in the atmosphere would block out the sun. Geologists have found traces of iron 60 isotopes in Antarctic ice cores, isotopes that could not have arisen naturally on Earth. That iron came from space, from supernovae. This means that in the past, Earth has indeed lost its shield. Some scientists link these periods to global mass extinctions and ice ages, when our planet turned into a white snowball, a so-called snowball Earth. The Voyagers are our only sentinels, our weather balloons. They are out there on the front line, checking the density of the medium. So far, they are signaling, density is increasing, but still tolerable. They are telling us that, straight ahead, there is no storm capable of wiping out civilization, at least not yet. But we do not know what will happen 1,000 years from now. In 2021, while continuing to listen to the radio emissions around Voyager 1, scientists at Cornell University discovered another anomaly in the data, something that made them shiver. Usually, the interstellar medium is silent. Bursts of activity occur only when our sun ejects a coronal mass ejection. The shock wave from the sun reaches Voyager about a year later, hits the plasma around it, and the plasma rings like a bell. The instruments register a sharp beep. But this time, the sun was quiet. There were no ejections, yet Voyager still heard a sound. It was not a sharp beep, but a monotonous, constant, low-frequency hum. Imagine a quiet, barely audible rain drumming on a roof, or the crackle of static electricity. This sound never stopped. The scientists concluded, this is the voice of the plasma itself. Interstellar gas is vibrating. It is in a constant, weak state of excitation. This discovery was revolutionary. It proved that the void beyond our system is not dead silence. It is a living, dynamic medium with its own unknown processes going on. Voyager is listening to the breath of the galaxy. This hum is very faint at the edge of the instrument's sensitivity, but it is there, and it is everywhere. This changes our perception. We are not hanging in emptiness. We are swimming in an ocean that makes noise. And that noise tells us about pressure, about the hidden energy that permeates the space between the stars. Now let's shatter the most popular myth about the Voyagers. You have probably seen news headlines. Voyager has left the solar system. That sounds proud. Humanity has defeated gravity and escaped its home. But astronomers just shake their heads sadly at those words. Technically, the Voyagers have left the Heliosphere. They have stepped out of the solar wind's domain. They have crossed the threshold of the house, but they haven't even reached the front gate. The gravitational boundary of the solar system is monstrously far away, and realizing this scale is truly dizzying. Imagine our solar system as a football field. The sun is a tiny coin at the center. Earth is a speck of sand a couple of centimeters away. Neptune's orbit is about the penalty area. The Voyagers are now somewhere around the goal line. They have only covered that distance. But the sun's gravitational domain is not a football field. It is the entire city that contains the stadium. Far beyond the planets, in the cold darkness, lies the Kuiper Belt, a swarm of icy bodies that includes Pluto. The Voyagers are already inside it. But even further begins the Oort cloud. This is a giant spherical shell of trillions of icy comets, drifting slowly around the sun, barely held by its gravity. That is the true edge. Let's translate this into numbers that make your head spin. The distance from Earth to the Sun is 1 astronomical unit. Voyager 1 has traveled 162 astronomical units. The inner edge of the Oort cloud begins at 2,000 astronomical units, and its outer edge ends at about 100,000 astronomical units. Do you see? It has flown 160 units. It needs to fly 100,000. If Voyager keeps its current speed, and it will because there is no friction in space, it will need another 300 years just to reach the beginning of the Oort cloud. To fly all the way through and truly, finally, irrevocably leave the solar system, breaking free of the sun's gravity, it will take 30,000 years. 30,000 years. Let's put that timescale into context. 30,000 years ago, Neanderthals were still alive on Earth. Homo sapiens had only just begun painting on cave walls. There were no pyramids, no wheels, no writing. And that same amount of time must pass into the future for this small piece of metal to break free. By the time Voyager exits the Oort cloud, humanity may have vanished. Our cities will have turned to sand, our languages forgotten. Perhaps we will have evolved into cyborgs or destroyed ourselves in a nuclear war. And Voyager will still be flying, in total silence, among icy boulders, in absolute darkness. This is a real prison. We are locked in not by a plasma wall, but by space itself. Distance in space is the most reliable jailer. Even light takes more than a year to reach the Oort cloud. The nearest star, Proxima Centauri, is 4.2 light-years away. For Voyager, a trip to the nearest star would take 40,000 years. And incidentally, it is not heading toward Proxima. Voyager 1 is aiming toward the constellation Ophiuchus. In 40,000 years, it will pass within 1.7 light-years of the star Gliese 445. It will fly by. It will not stop. It will not go into orbit. It will just zip through that system and continue on into infinity. Voyager 2, in the same 40,000 years, will pass near the star Ross 248, and after 296,000 years, it will pass Sirius, the brightest star in our night sky. Imagine nearly 300,000 years of flight. In that time, geological epochs could change on Earth. Continents will shift, and Voyager will still be flying. It is a loneliness of a level that the human mind cannot fully digest. We have created things that are immortal compared to us. And this brings us to the final, most touching and philosophical part of our story: what these spacecraft carry on them. But before we talk about eternity, let's return to the present. Right now, at this very second, the Voyagers are dying. It is a slow, agonizing death from exhaustion. Their power sources, the radioisotope generators, are inevitably degrading. Plutonium decays, heat becomes scarcer. Thermocouples wear out. We lose about 4 watts of power every year. That may not sound like much, but when every watt counts, it is a death sentence. Currently, the probes have less than 250 watts left. That is not enough to power all systems. NASA engineers have to play a cruel game. They must choose which organ to amputate so that the brain can keep living. First, they turned off the cameras. The Voyagers went blind back in the 1990s. No more photos. That was painful but necessary. The cameras consumed too much. Then they began turning off the heaters for the scientific instruments. That was a huge risk. The instruments were designed to operate at positive temperatures or at least a slight negative. Without heaters, the internal temperature dropped to -5060 degrees Celsius. Everyone thought the instruments would die, lubricants would freeze, circuit boards would crack. But to everyone's astonishment, the cosmic ray and plasma detectors kept working. They turned into frozen zombies, functioning despite all the manuals. That is a testament to the genius of the 1970s engineers. They built for the ages, but you cannot fool physics. The power keeps dropping. In 2023, NASA used a hack. They sent a command to Voyager 2 to disable a voltage protection circuit, allowing it to tap a small reserve of energy kept for emergencies. That is like drinking the last canteen of water in the desert. It will extend the instrument's life by a couple of years, until about 2026. What then? Then a cascade of shutdowns will begin. First, the plasma detector will fall silent, then the magnetometer, then the low-energy particle detector. It is expected that by around 2030, at the latest 2032, the last scientific instrument will be powered down. Voyager will cease to be a scientific tool. It will stop sensing the cosmos, but it will still be alive. This transmitter will still work. It will send to Earth only a carrier signal, a simple tone. I am here. I am alive. Then there will not be enough power for that either. The transmitter will go silent. Or, more likely, the spacecraft will not have enough energy to keep its antenna aimed precisely at Earth. The communication beam, thin as a needle, will drift off, and we will lose it forever. It will become a dead piece of metal, drifting among the stars. But in fact, it is precisely at that moment that its main mystical mission will begin. On board each spacecraft, prominently mounted, is an aluminum housing. Inside is an object that has become a legend, the Voyager Golden Record. It is a 12-inch disc made of copper, plated with gold to protect it from cosmic corrosion for billions of years. Along with the record, a needle and a cartridge are packed, and on the cover is engraved an instruction manual, a language based on physical constants that any advanced civilization should understand. The transition frequency of the hydrogen atom, a diagram of the location of our sun relative to pulsars. So what did we decide to tell the universe about ourselves? If you find this disk a million years from now, what will you think of the creatures who made it? The selection of content was overseen by a committee headed by the legendary Carl Sagan. They had only a few months to compress the entire history, culture, and biology of Earth onto one copper disk. The record contains 118 photographs, but not as digital files. They are encoded as analog sound. To see the pictures, aliens or future humans would have to play the disk and decode the sound waves back into images. There are photos of the solar system's planets, diagrams of human anatomy, a man and a woman. NASA forbade sending them naked because of 1970s Puritan censorship, so they are just silhouettes. There are pictures of food, architecture, animals, an airplane, a train, an X-ray image. But the most important part is the sound. The soundscape of Earth. The authors recorded sounds we have stopped noticing but that define our lives. Rain and wind, a crackling campfire, the rumble of a train, a kiss, a baby's cry and a mother's soothing voice, a dog barking. There are greetings in 55 languages, from ancient Sumerian and Hittite to modern Russian, English, and Chinese. Short phrases, greetings, star travelers. We wish you peace. And of course, music. Music is the universal language of emotion. The choice was agonizing. How to pick 27 tracks to represent all of humanity. There is Bach and Beethoven, Mozart and Stravinsky, but also jazz by Louis Armstrong, blues by Blind Willie Johnson, rock and roll by Chuck Berry, Johnny B. Good. There is folk music, the singing of pygmy women from Africa, Peruvian panpipes, Azerbaijani mugam, Georgian choral singing, chakralo. It is an eclectic, strange, but incredibly vibrant playlist. But the record contains something even more intimate. And Drew Yen, the creative director of the project and later Carl Sagan's wife, proposed recording the electrical activity of a human brain and heart. She hooked herself up to an EEG machine and recorded her thoughts. She thought about the history of Earth, about the atrocities of the Nazis and poverty, but also about love. At that moment, she had just realized she was in love with Carl Sagan. So this electrical snapshot of a woman's loving brain is now engraved in gold and flying through interstellar darkness. That is possibly the most romantic gesture in history, an electrochemical signal of love that will outlive Earth itself. However, this metal has a dark side. On the record's cover, besides the playback instructions, a map is engraved, pulsar map. In the center is the sun. From it radiate lines to 14 pulsars, neutron stars that spin at breakneck speeds and emit radio pulses with the precision of atomic clocks. Next to each line, the pulsar's frequency is encoded in binary. Knowing those frequencies, any advanced civilization can locate those beacons in the galaxy and, by triangulation, calculate the exact coordinates of the solar system. Moreover, because pulsar frequencies slowly change over time, they could even calculate the precise date of the spacecraft's launch. We literally drew an arrow. We are here. We live here. Come visit. Many scientists, including Stephen Hawking, criticized this decision. They called it madness. Hawking warned, "Meeting a more advanced civilization could be for us what the arrival of Columbus was for the Native Americans." And that did not end well. We assume innocence, that a higher intelligence must be kind and humane. But evolution on Earth teaches us otherwise. The fittest survive. The predator eats the prey. And a technologically more advanced civilization, upon contact, always absorbs or destroys the less advanced one. This brings us to the dark forest theory, described by science fiction writer Liu Cixin, but with serious scientific underpinnings within the Fermi paradox. Imagine the universe as a dark forest. Every hunter creeps silently, trying not to give himself away, because there are other hunters in the forest. If a hunter sees movement, he shoots without hesitation to eliminate a potential threat. In such a forest, silence is the key to survival. Shouting, "I am here," is suicide. Perhaps that is why the cosmos is silent. Not because no one is out there, but because everyone else is smart enough to stay quiet. Everyone who shouted has already been eliminated. And we just sent 2 shiny probes with the exact coordinates of our home right into the heart of that forest. And on top of that, we have been mindlessly broadcasting radio signals into space for 100 years. The Voyagers are our naive, childish attempt to make friends. We are reaching out into the darkness, hoping that our hand will be shaken, not bitten off. But what is done cannot be undone. Voyager 1 cannot be stopped. It is flying away from us at 17 kilometers per second. The map has been sent. And even if it was a mistake, it was a magnificent mistake. A mistake born of hope, not fear. On February 14, 1990, when Voyager 1 had already finished its primary mission and was heading toward the edge of the system, it was 6 billion kilometers away, beyond Neptune's orbit. Carl Sagan persuaded NASA to take one last picture. It was technically difficult. The camera platform had to be turned back toward the sun. There was a risk that the bright sunlight would burn out the optics. Engineers resisted. Why waste precious time and resources on a photo of emptiness? There's nothing to see anymore. But Sagan insisted, and Voyager took a series of images that together made up a family portrait of the solar system. In one of those images, in a scattered ray of sunlight reflecting off the camera optics, a tiny, barely visible dot appears. It is smaller than a single pixel, 0.12 pixels. That is Earth. Looking at that image, Sagan wrote words that have become perhaps the most powerful philosophical manifesto of the space age. Listen to them, picture that image. A vast, grainy emptiness and a small speck of dust. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust, suspended in a sunbeam. This photograph destroys our ego. Think of the rivers of blood spilled by generals and emperors so that, in glory and triumph, they could become momentary masters of a fraction of that dot. Think of the endless cruelties inflicted by the inhabitants of one corner of this dot on the barely distinguishable inhabitants of another corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatred. Our posturings, our imagined self-importance, the illusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Voyagers gave us not only scientific data about plasma and magnetic fields. They gave us a mirror. They flew so far that we could turn around and, for the first time, truly see ourselves, see how fragile we are. The wall of fire at the edge of the system protects this dot, but it also isolates it. We are alone, at least for now. What awaits them? As we have said, in a few years they will fall silent forever. Their thermal hearts will cool. They will become icy lumps of metal. But in space, death is not an end. It is a transition to another state. In a vacuum, there is no oxygen to oxidize metal, no moisture to cause rust, no wind to wear down the surface. The only enemies are micrometeorites and cosmic dust. They will slowly, atom by atom, erode the Voyagers' hulls. But that process will take millions of years. The golden record is under an aluminum cover, well protected. Calculations show that erosion will not erase the information on the disk for at least 1 to 2 billion years. A billion years. In a billion years, the sun will be 10% brighter. Earth's oceans will begin to boil. Life on the surface will become impossible. Our planet will turn into a scorched desert like Venus. Humanity will most likely be long gone. Either we will have left for the stars or we will have vanished. And the Voyagers will still be flying. They will outlive our civilization. They will outlive our biosphere. They will even outlive the sun itself. In 5 billion years, the sun will swell into a red giant, engulfing Mercury, Venus, and probably Earth, then shed its outer layers and become a dim white dwarf. The solar system will die, but the Voyagers will already be far away. They will circle the center of the Milky Way. One orbit takes 225 million years. They will become eternal monuments to the fact that once, around a yellow star, there lived a civilization that managed to overcome gravity, that was brave enough to send a message into nowhere, and loving enough to include the sound of a kiss in that message. Perhaps, billions of years from now, when the galaxy is completely different, some alien spacecraft will intercept this strange ancient artifact. They will bring it aboard. They will see the diagram. They will place the needle on the record. And in the silence of their control room, a voice will sound in a dead language. Hello, children of planet Earth. And Chuck Berry's music will play. And we will be alive again, if only for the minutes the music lasts. The story of the Voyagers is not just a story about technology. It is a story about overcoming boundaries. First, we overcame Earth's gravity. Then we overcame the asteroid belt. Then we overcame the sun's pull. And finally, we overcame the heliosphere boundary, that very wall of fire. We are human. We are explorers. We are cramped inside any boundaries. Right now, as you watch this video, Voyager 1 is more than 24 billion kilometers away from us. A radio signal takes 22.5 hours to travel from there. The light you see from the stars is ancient, but the darkness through which Voyager flies is even more ancient. It is paving the way. Perhaps, thousands of years from now, ships with warp drives will follow its path. And the passengers of those ships, as they pass the coordinates where the ancient probe drifts, will salute it. But there is one question that haunts us. If we could send spacecraft beyond our bubble, if we could announce ourselves, why has no one done it before us? Why, despite billions of stars in our galaxy alone, have the Voyagers encountered only silence and plasma? Where is everybody? Why is the dark forest silent? And is there really anyone out there in the darkness? Or are we the only intelligent beings for millions of light years, locked inside a squashed croissant of the heliosphere? That question, the Fermi paradox, deserves its own deep and frightening discussion. And that is exactly what we will talk about in the next video. We will dissect theories that will make your blood run cold, from the zoo hypothesis to the great filter. If you don't want to miss that analysis, subscribe to the channel and hit the bell. Meanwhile, look up at the night sky and remember that out there, in the endless distance, a little piece of us is flying. Thank you for watching.